Everyone. Today we continue the system requirement. Remember, next Wednesday, you should submit the first version of requirement document. And well, now I show you again. Okay, could you see my screen? Hello, everyone. Okay. For the first version, this is requirement document. First version, you do not need to finish all of the subjects. You only need to select some part and try to fill the blank. Normally, you should do some work about functional and non-functional, but you don't need to completely finish it. In today's class, I will give you some example about how to write the NL. That means the natural language specification, and also give you some example about structured language specification. So after the class, you will know okay how to write the NL specification like F1, some function, F2. Some function, you will describe it, and you will also use the structured language like F1 structured language, or you even can use the tabular style to do the specification. And the non-functional requirement, I already give you the term template. So you only need to focus on such aspects like privacy, availability, scalability, maintainability, interoperability, and some software requirements like MySQL, IDE, and other else. And the last, what the hardware this software need in the runtime environment. This is the requirement documentation. Okay, then I continue. Today's class, I will introduce you how to give you some example about the functional requirement, how to use natural language, and how to use the structured language. You know, in the requirement, functional requirement, there are two types. The first type is actually this one, user requirement. Normally, we only need to use natural language, okay? Natural language to describe the user requirement, because this user requirement mainly for the end user to read. So it is good to use natural language because the end user do not understand the professional term. So for writing the user requirement, you are suggested to use a normal natural language. But in the natural language, you should give some standard format and to notice what term you use, like shall means that it must be done, and should, it means desirable, and sometimes use some text highlight to do the document. Remember, avoid using of computer jargon for user requirement. At today's class, I will introduce you the system requirement. You should know that system requirement is not for end user to read. It's not for customer to read. It's for development team to understand. So the system requirement actually has more detailed specification of system functions. And the constraint should be clearly defined by some structured language. The system requirements are intended to be the basis for designing of the system. So that means when you finish the system requirement, you can accord to the system requirement to design your system. And the system requirement may be also defined or illustrated. Means the example, e.g. using the system model. This model actually is some diagram like this. Some like DFD, date flow diagram, like a sequential diagram, and user case diagram, something like this. Using this system model to describe some system requirement. And this class, I only teach you how to use language, use some structured language. System requirements and the design, what's the relationship? In principle, in theory, requirements should state what the system should do, but the design should describe how it does this. That means in the requirement, in the first iteration, you only to organize, only to identify what the system should do. This is only work you need to do for the first version and the second version also. But in the design iteration, design process, you should answer how the system done it. That means you should design the ER model, you should design the entity, you also need to design some workflow and some data flow, and also you need to design the database. That is the design process. In practice, however, requirements and the design are inseparable. That means they may be in the same stage. When you do some system requirements, you will go into the design. I mean the early design when you do the system requirement. This is because a system architecture may be designed to structure the requirements. Okay, this means the architecture is based on your structured requirement. And the system may interoperate with other systems that generate design requirements. Normally, we develop a software product. That software product normally are not independent one. It always interoperate with other systems. So when you do the requirement, you will publish some so-called interface. That means the system interface among the different systems. This is a requirement. And based on this interface, you also need to design the interface into the programming language. You will see later. If you use a natural language, only use natural language to describe the system requirement, you will face many problems. However, when you write the user requirement, you can use natural language, no problem. But when you write the system requirement, if you still only use the natural language, you will get some problem. Here, ambiguity. What does this mean? It means the reader and the writers of the requirement must interpret the same word in the same way. However, natural language is naturally ambiguous. So this same way actually very difficult to meet. The other problem is over flexibility. That means the natural languages over flexibility. The same thing, or same function, or same requirement may be said in a number of different ways in the specification. The next chapter I will introduce you because there are different peoples involved into the software development. So the same thing from the different peoples may be different. The last one is a lack of modularization. Natural language structures are inadequate to structure system requirement. That means you only use natural language, it's hard to describe the system requirement. So the solution, what's the solution? If we're doing the system requirement, there are four alternative ways. Wait a moment.你看一下培养方案，这个课应该不是培养方案这个学期的，正在上的课。Okay, there are four alternative ways to substitute the natural language. The first one is a structured natural language, means a structured language. This approach depends on defining standard form or template to express the requirement specification. And you can also use some design description language. This is more formal. This approach uses a language like programming language. It's also called a procedural code, but with more abstract features to specify the requirement by defining an operational mode of the system. However, this approach is not now widely used. Also can be useful for interface specification. This means when you use this so-called design language, it's a programming language like. It's easy for development team to understand, but when you need to communicate with your end user, with your customer, you give them this kind of description. They will not understand, very hard to understand such kind of programming language like. So this is not widely used today, The third way is so-called graphical notation. A graphical language supplemented by text annotations is used to define the functional requirement for the system. An early example of such graphical language, such as SADT. Now we still use this kind of graphical notation way. Now we use this one, user case description. This is called a UC diagram, sequential diagram, SD, and also DFD, and others. The last one is mathematical specification. This kind of mathematical specification, normally in the real project, we do not use it. This only be used in academic or only used in school, university, or research center. Such kind of mathematical way is not a normal way for the real project because even for development team members, they will hard to understand mathematical description. So from this slide, I recommend you when you're doing the system requirements, first you can choose this one, use this one, structured, and also with graphical, structured and graphical. Structured language specification. The freedom of the requirement writer is limited by a predefined template, or we can say predefined form, or template for the requirements. That means when you use a structured language, writers cannot do freedomly. They need to follow the predefined template or predefined terms to doing so. All the requirements should be written in a standard way, not a paragraph, not to do the system requirement like you're writing a Nova, writing some documents, you can use a paragraph. No, do not use a paragraph. You should use some form or use some table, or use some form, use some table to describe. The terminology used in describe may be limited. So you should unify the term you used in the structured language specification. The advance or advantage is that the most of the expressive of the natural language is maintained. So it keeps the flexible, but a degree of uniformity is also imposed. So when you use a structured language, you can keep the flexible and also you can keep the uniformity. I give you one example about the structured language. Structured language to describe a functional requirement. Okay, here everyone can see this picture. This is a so-called IoT. IoT is have you heard about IoT before? Internet of Things. Internet of Things. IoT box. It's a kind of devices. It's kind of device. For this device, it provide many functions. One function is to log in. User can log into each box. With some verification information. So when you describe the login requirement, I say this is a function one. Functional requirement one. How to describe it in the structured language? First, you give the name. What's this functional requirement's name? It's called the F1 log to log into the IoT box. Okay, then you predefine. This is predefine. Predefine some form or template. Form. Then you give the attribute like the first one, A1, A2, A3, A4. A1 is for the precondition. Precondition means that you need to put some URL to get the login page. Then A2, you must input something For this function, you need to input the verification information, okay? Verification information. And the third, you need to if you put the correct verification information, then you will get the output. The output is the status of the verification. After you log in, you will have a post condition. Post condition means, okay, the function is to redirect to the main page. Redirect to the main page. Okay, this is a very classical structured language, SL, structured language describe a functional requirement. Everyone have a look. Do you have any questions? Okay, if no questions, I continue. This is one kind of structured language, and you can doing more detailed. I will give you a real example. Real example about system requirement written in structured language. Everyone, look at here. This is a real example. This is a function f1 to log into the box. Log into the box. This is function. So here, give a URI for login. Actually, you can see it's not going to only log in. It will get a token here. So first, this is URI. You clearly write in the URI here. Then this is a parameters. Parameters explain what this ID server mean. ID server actually is a kind of IP address. Then the method you should use is HTTP method. You should use post. Then HTTP headers, you should set none here, very clearly, precisely specify the parameters. And the bodies, HTTP body here, you should submit what kind of verification information here. You see, username, password, scope, client ID, client secret, grant type, many parameters you should send here. This is verification information. And also some remark here. It means the HTTP content type should be this one. This is a kind of standard. This actually is IEEE standard application X sum W form. This is the format of the body. This one, format of the body. And if you log in to have the success here, then you will get the response. Response here. Response have some predefined parameters. First one is access token. Expire in this means after this data, the access will denied. Refresh token and the token type. If your login is failed, you will get this information. Information code is 429. That means that the server refuse your login. And also doing some remark here. This means the access token will be expired in 2 hours. 2 hours. This is a real structured language for system requirements. Okay. I hope you can doing your homework, your project like this, like log in, like assign a class, like select a course. You can doing like this. You can doing like this. Very clearly, precisely. It's no ambiguous, no ambiguous. Okay. Any questions about the structured language for these two examples? Everyone can see when you done the requirement like this, very clearly, very precisely, it will convenient for both customer and you to go into the design process. Because from this system requirement, you can know, okay, this function, I can define this function in the programming language. You know the parameters, you know the argument, and you know the input, you know the output, and you know everything. Then you can follow this system requirement to design. You can use Java language to design. You can also use Python to design such kind of function. And then when you finish the design, you can go into the implementation. Then you can really write down the code. Really write down the code. Okay, no questions for system structured language. What's here structured language? Let me open the requirement document again. Requirement document again here. Everyone should know here, for each functional requirement, I ask you not only use a natural language. Natural language actually just for user. This is for system. Not only use natural language, but also use a structured language. The same function, F1, you should F1 again, but in different way. Is that clear? Is that clear for your homework? Hello, can you hear my voice? Hassan, okay. Tawfiq, how about you? Anik, Andy. Okay, I'm keep going. The last one, Last one is the tabular specification. This is more stricted than structured language, more and more stricted than structured language. This kind of tabular specification only used in some complex requirements, like this one, because such like login is very easy. You can use structured language to easily describe it. But sometimes some systems, some functions are more complex. You cannot only use structured language to describe it. Like this one, everyone, like this one. This one actually is a so-called is a machine control system here. This machine control system is to inject some drug into your blood. This drug can do a thing, can reduce your blood sugar level, blood sugar level. Okay, this device is called a blood sugar pump. What it can do, it's very difficult to use natural language to describe. So it uses so-called tubular specification. What does it can do? For the condition when your blood sugar level falling rate is this one, then the control system do not inject the drug into your blood. And when your blood sugar level stable, it's like this one, R1 equal to R2, then it still keep silence, do not do anything. And when your blood sugar level increasing means you need some drug, but the rate of the increasing is like this, not very high. The system control still keep silence, do not inject any drugs. But if your blood sugar level increasing rate is stable or increasing, very quick means the calculation formula is this one, calculation formula. Then the system controls the pump to inject some drug. The drug, how to inject is according to this formula. This is a very strict system requirement specification. It's called a tubular specification. Only be used when the function is very complex. The normal structured language cannot describe it. You can consider to use such kind of specification. It's called a tubular specification. For the system, when you're doing requirement, you can use natural language, you can use structured language, you can also use tubular. But sometimes such kind of language is not enough, especially when your system need to be interact with other system. Because most of system must operate with other system. And the operating interface must be specified. Okay, everyone. Here, this interface not means the UI. No, not UI, not user interface. It is a system interface. So it's not the show, not display to you, but it's more like an exchange among the different systems. There are three types of interface may have to be defined. First one is normally used, it's called a procedural interface, like function. Like one system, A system, will invoke B system. So how A invoke B system? They will according to a function. So you will define a function interface, And maybe sometimes they will not invoke the function. They only need to transfer data from A system to B system. Then you will define the data structure for exchange. For today, there are several ways to define this so-called data format. Maybe you can use XML, this kind of format. Also, you can use JSON format to exchange or transfer data from one system to the other system, sometimes from the client to the server. And the last one is the data representation, like how to represent an image, how to represent a video, different kind of data representation. And the formal notations are effective technique for interface specification. Here, this is an example. This is example. Example of what? Example of procedure interface. This example is for print something. How to print? This print server may be in A system, but other system, maybe B system, will use this so-called print, prints. How can it use it? It will invoke different method here. You see, different method. You can first, you need to initialize. Then you can do the print. And you can also display the print queue. And when you do not need to print, you can cancel the print job. The B system can invoke the interface from A system. This is a very classical procedure interface defined by the interface specification. Different language have a different way. Even you needn't use a specific programming language. You can use a procedural language to describe it. It doesn't matter. So for the interface, any questions? This is interface. This interface actually is a C++, interface. Okay, we continue. The last part is the requirement documentation. The requirement documentation is the official statement when you after the requirement analysis. What is the required of the system developer? It should include both a definition of a user requirement and a specification of system requirements. It is not a design document, you should understand, because as far as possible, it should set of what the system should do rather than how it should do. The first one should include the user requirement and the system requirement. Okay, here. This template documentation, I already sent it to you. Here, this is the user requirement. And here is the system requirement. You should include both two of them. Okay, then end of this chapter, the requirement documentation. The key points, let's have a review. First, Requirements set out what the system should do and define the constraint. What means constraint means? Everyone look at here. I already give it to you. What's the constraint? Here. These are one kind of constraint. One kind of constraint. Functional requirement set out a service or functions the system shall. Everyone, shall. Shall, not should. Shall means that you must provide. Non-functional requirement constrain the system being development. It means that you should fulfill the constraint. The user requirement are the high-level statements of what the system should do. But user requirement should be written in language, natural language, and sometimes you draw some diagram, and maybe you can use tables. The one principle is to make it simple that the end user and the customer can understand it. Okay, this is this chapter, user requirement documentation. Next chapter, next class, I will teach you how to do the requirement process. It's actually an iterative process. It's like from requirement discovery, requirement analysis, requirement classification, and requirement validation. Then you will go a loop. You go back again to the discovery, and go to the design, and go on. It's like a sparrow. It's like a sparrow. This one. Sparrow. Sparrow. It's like a sparrow. Like this. Okay. We take a break. Take a break. 10 minutes. Have a rest, everyone. Everyone should submit it independently. Okay? No group. No group.
Lauji, are you here? Can I ask one question?
Yes, yes.
I want to ask you just about the next homework. It will be about the content of the last project, right? We should to submit document about our last project.
Mm-hmm.
Okay, our last project will every group will make one project. So about the documents, we need to do it individual work.
Yes, individual work.
Okay.
Lasha, so if the document, if this PPT, if this PPT is about our final project, shouldn't it be like every group should write only one PPT? Because right now, if everyone did write one, it will be almost the same for every 4 to 5 people. It will be almost the same.
No, no, no. It will not same. It will not be same. Different people have different because you write in natural language, right? It's different. Different. The content is the same, but the way you're doing it, it's not the same. Not the same.
Okay, and
Okay.
our final project is an open topic of we can choose. So
Not the open topic. I already sent it to you. That project.
No,
But
he
the
sent to
language,
already sent to us PPT, yes.
not PPT. I
yeah,
already sent you the
yeah,
project
I
instruction.
yeah, sorry, I had some confusion about that.
I send it again. Okay. Project
Okay, thank you.
instruction. This one. Everyone doing the same project, but you can choose a different language, different framework to implement it.
Okay, so the groups are can be 4 to 5 people.
Only one, only you, self.
No, I
No
mean the
group.
final.
The final also the same.
Oh, okay, okay, I understand.
This is the final. This final is actually iteratively doing the final project. You know what is iterative?
So
Iterative like version 1, version 2, version 3, like this.
I
Actually,
see.
no, you are doing the final.
Okay, I understand. Thank you.
Okay, everyone, let's continue. This chapter we are talk about how to doing the requirement documentation. It is a process, right? It is a process. Actually, this process It's called iterative, as I said, it's like a spiral, like a circle. It's like this. Not a single line, not a single line. It's like iterative. So what activities in this iterative? Let's see here. There are 4 activities in this process. The first activity is the feasibility studies. It means that you will check, you will analysis. Does this project feasible? Does this system feasible? Okay, this is the first thing you need to check. Then after you check it feasible, then you are doing the requirement analysis. What is a functional? What is a non-functional requirement? You should identify. When you identify the functional and the non-functional requirement, you will write it down, and output the specification. As I said, you can use natural language, you can use the structured language, and you can use a table to write down the requirement specification. After it, you are going to requirement management. This means that sometimes, not sometimes, normally the requirement may be changed or maybe update. Then if you change, if the requirement change and updated, you need doing again from the feasible analysis, feasible study analysis, and the specification again. It's like iterative, 4 topics in this chapter. Requirement engineering process. It is a process used for requirement engineering very widely depending on the application domain, the people involved, and the organization developing the requirement. So this requirement not only yourself, but also involved the different people in this project, mostly involve the market and the customer. However, there are a number of generic activities common to all processes. As I said, the first one is the requirement feasibility. The second one is a requirement analysis. 1, 2, 3. The third one is the requirement specifications. And the last one is management the change. Management the change. The process normally like this. Everyone. You see, first you doing the feasible study. Does this project can be done? Can be done in the budget. In the budget can be done, or in the current technology. Does it can be done? If it can or cannot, you will give some report. But in this class, we do not use this feasible report because the project I send to you, it can be done. Okay, it can be done. So it's feasible. It is feasible. After it, you are doing the requirement analysis. Actually, this analysis, what it should do, it's doing discovery to find out how many functional, how many non-functional requirements. Based on the project instruction I already sent to you, most of discovery work already done. You only need to simply classify it into function and non-function. Very simple. And the next chapter, I talk about the system model. You can choose one. I can choose one to try to use the system model. And after you discover the requirement, you will write it down. Write it down becomes a requirement specification. You can use NLSL tabular or the form, some form to write it down. And you also need to category divide the specification into two types. One is user type, user requirement. The other is system requirement. Two are one and two. After the system specifications, we are going to the management, also called a validation, and some changes here. You see, it will have a backward. This backward means when you discover the requirement, you write it down and you find, okay, it is incomplete. Then you will go back to the discovery again. Even when you finish the specification, when you validate it, when you send it to the customer, then customer told you, okay, the market change and the customer may have new requirements. Then you will go back again to modify it. You will see it has a backward. It's like a loop. First, we will talk about the feasibility. Also, in this class, you don't need to do so, but you should understand that if you're doing real project, you should know the feasibility is the first step, very important step, because the feasibility study decide whether or not the proposed system is worthwhile. A short focused study that can check three ways. The first aspect you should check if the system contributes to organizational objectives. This means the customer told you they want a system and the function they want. Then you will check when you finish this term, when you finish this system, when you finish all the functions they ask you, then does it can fulfill the objective of the customer? Because the customer actually don't really know the system. They just know, okay, what functions they want. Then you check the function, then you can analysis. When you finish all the function, does this system can really fulfill all the objective that the customer wants? If you found even you finish the project, even you finish the system, this system cannot fulfill the customer. That means it is not worthwhile. It's not worthwhile. That means you finish it, you may not get the money. You may not get the money because the customer were not satisfied by the system you development because they actually do not really know what they want. This is first, you must check. Then second, you must check if the system can be engineered using what? Current technologies and within the budget. This is very important because when you go into the company, your company will handle a project, system project. They want to get money, right? If you find, okay, today, current technology cannot support such complex system, that means you will probably over budget because you will research. You are doing many extra research to develop a new technology to support such complex system. This will case over budget. This is very bad situation. You are doing a project, but you didn't get money. You even put money by yourself. This is not a good idea. So you must check current technology. Does current current technology can support or cannot support such complex system. This is second thing you must check. And the third thing is you must check if the system can be integrated with other system the customer already used. This is also very important. For example, a customer asks you to develop a MES system, but in the customer company, they already have ERP system. They also have the selling system, So when you done the MES system, you must consider, does this MES system can be integrated with the existing ERP or selling system? If you cannot integrate it, the system you developed is useless. So you must consider, you must check whether you developed this MES can be integrated with the existing ERP system and the existing selling system. So this is 3 aspects before you really doing the project. You should do this feasibility studies. Any questions about these 3 aspects? The second activities actually is analysis. Analysis is abstract terms. In fact, this analysis actually doing what things? Doing discovery. Discovery what the system should provide. Okay, some students ask me what is ERP, what is MES, what is the selling system. Okay, everyone, I think you know what is the selling system, right? Suppose that your customer is a company. This company provides some product to selling in the market. So they must have a selling system, right? Selling system, the sell the product of them produced. And what is ERP? Who can tell me? Actually, every company today, even the university, even our university, has the ERP system. Do you know what is ERP? ERP called Enterprise Resource Planning System. It is to manage all the resources of the company, including the people, the staff, the facilities, the department, device, and other estate of the company. This is a comprehensive system that every company has because it's control to manage all the resources in the company. What is MES? Not all the company has this MES. MES actually only the produce or factory can have this system. M means the manufacturer environmental system. Okay, it's to control the machine to produce the products in the factory. This is a MES system. Is that clear, guys? There are
Yes,
many,
Rashid.
many, not only these three, not only these three. Okay. So the second activity, when you first activity, you know whether this project is worthwhile to do, If you check, okay, it's worth to do, then you're going to do the analysis. Analysis is to discover the requirement. Here, there is a question here. Because the project is a customer ask you to do, why we need to discover the requirement? Why cannot the customer tell you the requirement? Who can answer to me? Everyone think. Why we need to do the discovery of the requirement? Why cannot the customer directly told you the requirement? Think, everyone. This is a very important question. Every software engineer should know this. Fahmi said, customer does not know exactly what they want. Other students agree or not agree?
Yeah, sometimes I think the same thing. It's like the customer wants a thing, but he did not know specifically what he wants.
Yes, Ali agree. Hassan agree. Yes, that's right, Fahmi. That's right. This is the realistic. This is real situation today. The customer, because the customer, they are not software engineer. They always think in their own way. Like if a bank wants a banking system, they always think in a bank way, not the system way. So they cannot directly tell you the requirement, especially the system requirement. Understand? They can simply tell you, okay, I want my system can save the money. I want my system can withdraw money. I want my system can transfer money from count A to count B. I want my system can do one thing. But this cannot be directly used to development, right? This is one aspect. The other aspect, the customer, not a single person. They maybe have the manager, they maybe have the customer, they maybe have the end user, they maybe have many, many different roles. Different roles have different thinking way. For the same thing, different roles maybe give you different answers. So this means the customer actually don't really know what they want. This is need you to go into the company, to go into your customer's company, to work with them, to find out by development team, to find out. This is very important activity. You will interview many, many different roles with the same requirement. Then you will summarize all the answers. Then you will organize the really requirement for the customer. So the important thing is when you're doing a real software project, the requirement is not given by the customer. Also, it's not given by development team. It's it's established by development team to negotiate with the customer. This is the realistic way to discover the requirement. Is that clear? To do the negotiate. The analysis involves technical stuff, working with the customer to find out about application domain, the functions the system should provide, and the system operational constraint. You going to the customer's company to working together to find out. Like our university selection, course selection system, it's 3 years ago. 3 years ago, they developed this course selection system 3 years ago. When they doing this course selection system, the development team, actually this team called the 精致 development team, they send more than 10 people, more than 10 development team into our university, working with our university staffs to find out what we really want, what the university really want. Then after 1 year working together, they finish this course selection system. The analysis also may involve end user. For the university system, end user are you and me, right? Managers, this is administrator of a university. Engineers, this is sent by the development team. Involved in maintenance, domain expert, trade union, etc. And there is a term, professional term. This term you should remember. This term called stakeholders. This means that all the people involved into the software project, they are stakeholders. There are many problems during the requirement discovery. This problem normally faced by the stakeholders, because the stakeholders are totally different. The first one you already knows. That means the stakeholders do not really know what they want. Stakeholders express requirement in their own terms. This will case the inconsistent requirement, because they can only stand on the perspective to tell you what they want. Different stakeholders maybe have different answers within the same functions. And the different stakeholders may have conflicting requirements. You will know later, I will give you some example. Organizational and political factors may influence the system requirement. And also, the requirement may be changed during the discovery process. And the new stakeholders may emerge. And the business environment also can be changed in the future. This will case the requirement discovery process. Let's have a look about a stakeholder example here. I think you know the ATM. ATM is a machine that you can save money and you can withdraw money and you can transfer money. Okay, ATM system. When you need to develop an ATM system, there are many stakeholders. You see here, the customer, bank customer, the bank managers, account staff, database administrator, security, marketing, hardware and software maintenance engineer, and the banking regulator. I give you one function here, one function, F1. It's transfer money. Okay, transfer money. Very simple function. But even for this very simple function, different stakeholder may give you different answers. Example is here. Suppose the bank customer, like you and me, we are bank customer. We want to transfer money from account A to account B. Our requirement is that the transfer should be convenient for us. We can very quickly transfer money from my account to the other account. I need only log in and transfer. That's enough. Very quickly, maybe 5 seconds, 10 seconds, I can finish it. But the security manager of the bank may have different answer. They will keep the transfer always safety, always in the security. So they will ask the development team to extra add many checking point, like not only login enough. They will have the second password. Second password is not enough. They will also ask you to provide USB key. Do you know USB key for the bank transfer? Maybe in the 2 or 3 years ago, if you want to transfer money in China Bank, you must log into the web page, the banking web page. Then you also need to plug in the USB key, security key. Only you plug in the USB key, you can transfer. If you do not plug in this USB key, you cannot transfer. So this is first one is the bank customer they want, but the bank security manager, the requirement is totally different. So what you need to do, to negotiate with the security manager and the bank customer, then you will get a balanced way, like today. You will this balanced ways is the result of the negotiate. Like today, I transfer money from my account to the other guy's account. Login is not enough, but also I don't need the USB key anymore. Instead, I need a cell phone. I will receive a dynamic code. Then I put the dynamic code. Then I can transfer the money. This is today's transfer function. So this is a different stakeholder have different requirements. As a software engineer, you need to negotiate with a different stakeholder, then you will get agreement. This agreement will state into the requirement specification. Is that clear? This is stakeholder. And the next is when you go to discovery the requirement, you will get the requirement like a viewpoint. This is an example. This is the library system. You will classify the different aspect. Like the library system, you will get, okay, indirect, the library manager, finance, article provide, and the interactor is you and me, user, student, staff, extra, these stakeholders, and the library staff, the system manager, and the catalogs, and some domain expert like US standard, classification systems. All of these are the stakeholder of this example library system. A different system has different stakeholders. As I said, the requirement process actually is an iterative process. It's not like a single line. It's more like a spiral. Like we start here, requirement discovery. This is the first activity. When we finish discovery, we know the requirement. Then we do the requirement classification and organization. And then we go into the third stage. We can negotiate with the customer, with a different stakeholder, and we can write it down. It's requirement documentation, also called specification. Then you find your specification, your documentation is not complete, means it's incomplete or it's not good. Then you will go into the discovery again, find some modification. You are going to this activity again, like iterative. And the more outer circle, the more completeness your document can get. So this is why I require you to do the version 1 requirement documentation, version 2 requirement documentation, because we're trying to follow this requirement spiral. I will tell you some method for doing the discovery. This discovery, the method is called interview. Interview is you going to the customer, talking with different stakeholders. This is called interview. Interview can be done informal and informal. The requirement team puts the questions to stakeholders about system that they use and the system to be developed. There are two types of interview. The first type is called a closed interview. Why a predefined set of questions are answered. So this requires you, before you go into the customer, you should analysis at first. Then you predefine some questions, like you list a function, you list the functional requirement, and going to the customer, you ask them stakeholders one by one. The other interview is called open interview, where there is no predefined agenda or range of issues are explored with the stakeholders. This open interview's purpose is to find or to discover the new requirement that you didn't consider. Understand? Because both of you and the customer do not really know the completely requirements. So you need an open interview. Then the customer will find some new requirement. Then you will record it down. Okay, for today, we finished here. And after this class, remember to do the functional and the non-functional requirement with the user requirement and the system requirement. Next Wednesday, before next Wednesday, you shall submit version 1 requirement documentation to TA, Ronnie. Remember, this is not simply homework. This is actually the final project. This is the final project because our final project divided into several steps. This is the first step. Do not forget to submit the version 1 requirement to Ronnie. Okay, everyone? And today, class over. And see you next Wednesday. Yes, Ronnie, that's right. Next class will be held Wednesday, 29th September. See you again, everybody.